Hello guys, welcome to Apex Math. My name is Pino. In this video, we go through question 3 from the August 2025 N4 Mathematics question paper. Question 3.1, we determine the value of x for the given trigonometric equation, and our x has to be between 0 degrees and 360 degrees. We have the 3 sin squared x plus 2 sin x multiplied by the cos x. We move the 4 cos x to the left, it will change sign to negative 4 cos x, and moving the 6 sin x, it will change sign to negative 6 sin x, and this will be equal to 0. For the first two terms, we can take the sin x as our common factor only for the first two terms. So we have sin x into 3 multiplied by sin x plus 2 cos x. Take note that we have 3 sin x and the 2 cos x. If we were to take negative 2 as our common factor on this term and that term, we might end up with 3 sin x plus 2 cos x. So we take negative 2 as our common factor, and inside we'll have 2 cos x plus the 3 sin x, and this is equal to 0. So we can rearrange. So we have sin x into 3 sin x plus 2 cos x minus 2. So we write that 3 sin x first. So we have the 3 sin x, and we later write the 2 cos x, and this will be equal to 0. So now we can take the 3 sin x plus 2 cos x as our common factor because it's common in both terms. So we have 3 sin x plus 2 cos x as our common factor, and we'll be left with the sin x minus 2 is equals to 0. From here we equate to 0, so we have 3 sin x plus 2 cos x is equals to 0, and we have the sin x minus 2 is equals to 0, and we have 3 sin x. We move the 2 cos x to the right, it will change sign to negative 2 cos x, and on the other side we have the sin x. We move the negative 2 to the right, it will change sign to positive 2. So we have a problem with the sin x is equals to 2. So let's draw the graph of the sin x. When we draw the graph of sin x, so let me draw the graph quickly. When we draw the graph of sin x, is between negative 1 and never at 2. So the sin x is equals to 2 is not a solution because 2 is above the graph of sin x. So this solution will not be accepted. So the solution that sin x is equals to 2 is inadmissible since sin x is between negative 1 and positive 1, and it never gets to 2. So we are left with this solution. And for this solution, it's either we divide both sides of the equation by cos x or by sin x. But if we divide by sin x, we'll end up with cot x. So let's divide by cos x so that we can end up with tan x. So on the left, the cos and the cos will cancel out. We'll be left with 3, and that sin x divided by cos x is equal to tan x. So we have 3 tan x is equal -2. To solve for x, we are going to divide both sides of the equation by 3, and that 3 and that 3 will cancel out, and tan x will be equal -2 divided by 3. Introducing the arctan both sides of the equation, x will be arctan of -2 divided by 3 plus k multiplied by 180, since the tan graph has a period of 180 degrees, where the k is an integer value from 0. So we have x is equal, the arctan of -2/3 is -33.69 degrees plus k multiplied by 180 degrees. So we were told that our x has to be between 0 degrees and 360 degrees. So let's not forget that. We start by substituting 0 where there is k, and our x will be equal -33.69. Now we substitute, so we have x is equal to -33.69 degrees plus 1 multiplied by 180 degrees. We substituted 1 for that k, and this will be equal 146.31 degrees. And when we substitute 2 in the place of the k, so we have 2 multiplied by 180 degrees. This will be equal 326.31 degrees. Now we substitute 3, so we have x is equal -33.69 plus 3 in the place of the k multiplied by 180 degrees. This will be equal 506.31. Remember that we were told that x should be between 0 and 360 degrees. So the -33.69 will be cancelled. So we cancel that, and we also cancel the 506.31 because it's above 360. So our x will be the 146 and the 326.31 because they are between 0 and 360. So those ones are not between 0 and 360. So our x will be an element of 146.31 and also the 326.31. And this will be our answer for this question. Question 3.2 states, if tan x is equal 5 divided by 12 and x is an acute angle, determine cos 2x without using a calculator. The key word here is the fact that x is an acute angle. So if it's an acute angle, then it's going to be in the first quadrant, because acute angle are angles less than 90 degrees. One of the rare trigonometric identities that we can use is the fact that cos 2x is equal 1 minus tan squared x divided by 1 plus tan squared x. If you are familiar with this trigonometric identity, you can use it. If not, then we do it the traditional way. So let's draw our quadrant. we are told that x is an acute angle, so we are in the first quadrant. From here, we introduce our secateurs, and tan is opposite over adjacent, so the 5 will be our opposite and the 12 will be our adjacent. We have to determine the hypotenuse, the r. By theorem of Pythagoras, we have r squared is equal x squared plus y squared, where our r squared will be equal the x, which is equal to 12 squared, plus y is equal 5 squared. We introduce the square root both sides of our equation, and r will be equal the square root of 12 squared, which is equal to 144, plus 25 is equal to 169. So our r is equal to the square root of 169, which is equal to 13. So our hypotenuse is equal 13. So now we can determine the cos 2x. We determine the cos 2x using that trigonometric identity and also using our diagram on the right. So we'll do it both ways. So cos 2x, we are going to use the trigonometric identity cos 2x is equal to cos squared x minus sine squared x. So this one you should be familiar with. In the place of the cos x, we have that secateurs. Cos is adjacent over hypotenuse. Our adjacent being equal 12 and our hypotenuse is equal 13. And this will be squared minus sine x. Sine is opposite over hypotenuse. Our opposite being 5 and our hypotenuse is equal 13. And this will be squared, and this will be equal 12 squared is equal to 144, 13 squared is equal to 169. So we have 144 divided by 169 minus 5 squared, we know it is equal 25, and the 13 squared was equal 169. 144 divided by 169 minus 25 divided by 169, 119 over 169. So cos 2x is equal 119 divided by 169. So let's use the trigonometric identity. So we have 1 minus, in the place of the tan, we are given that tan x is 5 divided by 12, and it will be squared divided by 1 plus tan is 5 divided by 12 squared. This will be equal 1 minus 5 squared is 25, 12 squared is 144 divided by 1 plus 5 squared is 25, 12 squared is 144. So this will be equals to 1 minus 25 divided by 144 is equal 119 divided by 144 divided by 1 plus 25 over 144 is equal 169 divided by 144, and this will be equal, so this is also equal 119 divided by 169. So cos 2x is equal 119 divided by 169. Question 3.3, we prove this trigonometric identity and we take the complicated side, the left hand side, and we use the trigonometric identity sin squared theta plus cos squared theta is equal 1 And we are going to make the sine squared theta the subject of the formula. So we have sine squared theta is equal 1 minus cos squared theta. So in the place of that sine squared theta, we'll substitute that. So we have cos squared theta minus cos theta minus, in the place of the sine squared theta, we substitute the 1 minus cos squared theta divided by the 2 sin theta cos theta plus the sin theta, and this is the left hand side. So we simplify. So we have cos squared theta minus cos theta. We distribute that negative, and negative multiplied by 1 is negative 1. Negative by negative will be positive cos squared theta divided by the 2 sin theta multiplied by cos theta plus sin theta. Okay, let's put that equal sign, and this will be equal. So that cos squared theta plus that cos squared theta will be 2 cos squared theta. So we have 2 cos squared theta minus cos theta minus 1 divided by, we take that sin theta as our common factor. So we have sin theta into 2 multiplied by cos theta plus 1. We factorize the numerator. The factors of the 2 cos squared theta. The factors of the 2 cos squared theta will be 2 cos theta and cos theta, and the factors of the 1 will be 1 and 1, and the signs. So let's start with negative here and positive here. So no, it's not gonna work. So we need positive that side and negative this side. So in the denominator, we still have the sin theta multiplied by 2 cos of theta plus 1, and the 2 cos theta plus 1 will cancel out each other, and will be left with cos of theta minus 1 divided by sin theta. Now suppose that we had a minus b divided by c. This will be equal a divided by c minus b divided by c. So even in our case, this will simplify to cos theta divided by sin theta minus 1 divided by sin theta, and this will be equal cos theta divided by sin theta is equal cot theta, and 1 over sin theta is equal to cosec of theta. So let's check what we were proving first. So we were proving, okay, we're proving 1 over tan theta minus 1 over sin theta. So we leave the 1 over sin theta. So we know that 1 divided by tan theta is equal to cot theta. So we can just substitute. So we can just substitute the 1 over tan theta in the place of the cot theta. So even that is sin theta over cos theta in reverse. So this will be 1 divided by tan theta. And this will be our answer. Question 3.4, we derive a formula for 1 over sec 2 theta in terms of sin theta only. So we know that 1 divided by cos theta is equal to sec theta. So when we cross multiply, we will find that cos theta is equal 1 divided by sec theta. We don't have sec theta, we have sec 2 theta. So 1 over sec 2 theta will be equal cos 2 theta. And we have a trigonometric identity at the formula sheet which states that if we have the cos, so they broke down the 2 theta as theta plus theta. So cos theta plus theta will be equal, according to the formula sheet, this will be equal cos theta multiplied by cos theta minus sin theta multiplied by sin theta. And this is equal, so that's supposed to be cos. So this is cos of theta. So cos theta multiplied by cos theta is cos squared theta minus sin theta by sin theta is sin squared theta. So we can change the cos squared theta because we want the thing in terms of sin theta. To change the cos squared theta, we use the trigonometric identity that we used on the previous question, sin squared theta plus cos squared theta is equal 1, making the cos squared theta the subject of the formula. Cos squared theta will be equal 1 minus sin squared theta. So in the place of that cos squared theta, we will substitute the 1 minus sin squared theta. Minus sin squared theta. So this will be equal 1 minus sin squared theta minus sin squared theta. This will be equal 1 minus sin squared theta minus sin squared theta will be equal negative 2 sin squared theta. We have finally expressed the 1 divided by sec 2 theta in terms of sin theta. And this will be our answer for this last question. Friends, thank you for watching. If you have any questions, you can drop them in the comment section below. Remember to subscribe, like, and share the channel if you find this content useful.